I'm Clayton Pierce, and this is video experiment number 6 and 7. The parts of this experiment is, first we have an electric motor, which is something that turns electricity into circular momentum with electromagnets. We have a transistor, which is a semiconductor device that can amplify or switch electrical power. In this case, it's a switch. We have LEDs, or light-emitting diodes, which give off light when powered. We have a regular diode, which only lets current flow one way, like a one-way valve. We have a potentiometer, which is a variable resistor that gives off different values depending on how the dial is turned. We have a button, which gives off high or low depending if it's pushed. In this case, when pushed, it gives off low. And we have a resistor, which resists current/flow of electrons. What this experiment does is it changes the speed of the motor depending on how much the dial is turned, and once this button is pressed, it toggles this LED indicator that the more power the motor has, the more LEDs go on, like a power bar. The way everything is wired up is, firstly, the potentiometer has the ground wire here and has a red wire connecting it to the 3.3 volt pin row. The row here is connected to the 3.3 volt pin with this wire here. And then it's being read with the analog port with this yellow wire here. The button is wired up with this resistor connected to 3.3 volt power, this black wire connected to ground, and this green wire here connected to digital pin 7 to read the button's high or low output. The LEDs, all 6 of them, are wired in the same way. We have a resistor connected to ground, and then we have a wire coming from the positive end of the LED connected to one of the digital ports, and every LED has it, so there are 6 wires in the digital port down here. The motor, however, is a little bit different. The motor is powered itself directly from the 5 volt power, and the ground wire of the motor passes through the transistor. So it can only work, the circuit's only completed when the base pin of the transistor is powered, because that allows the ground current to flow through the transistor to the ground of the board. The purpose of the diode here is because when a motor stops being powered and continues to spin, it generates electricity. That's how a generator works. So if you didn't have this diode protecting the transistor, electricity would flow through the ground to the transistor when it shouldn't and damage it. So we have this diode to push the electricity back to the 5 volt pin when the 5 volt pin's not on. Now it's time for the build section. This is video experiment number 6 and 7, how to use a transistor and how to use a button to toggle. As you can see, starting with the potentiometer, it's wired up to ground with this gray jumper wire here. This gray jumper wire is connected to ground with this other gray ground wire way over on this end. The potentiometer is connected to power through this red wire, which is connected to the 3.3 volt pin on the board with this red wire here. The potentiometer is being read by an analog port here using this yellow wire connecting to the middle pin of the potentiometer. The button is wired with this resistor connected to the 3.3 volt power, same as potentiometer, and then what's reading the button value is this yellow wire here connected to digital port 11. And the button is connected to ground with this gray wire here. The motor is connected with this big red jumper to the 5 volt pin on the board. There's a diode in the middle so that if the motor is turned off, all electricity will go back into the 5 volt and will not go through the transistor when it shouldn't go. And then there's a jumper connecting the 5 volt to the motor, and then the black wire connecting to ground on the other side of the diode, which when powered, and it's supposed to have current flow, will go to the transistor. This will be powered, allowing current to go through the transistor, and it will go to ground, same as the potentiometer and button do. The LEDs are all wired up in the same way. Each one has a resistor connected to ground and a wire connected to a digital port on the board, and they're all color-coded. So the green 2 are connected to the green LEDs, yellow connected to yellow, and so on. What this experiment does is if you turn this potentiometer dial, it increases the speed of how fast the motor is spinning until the max speed here.
And if you toggle this button, it turns on the LED indicator, kind of like a power bar, as you can see here. Looking at the serial monitor, you can see that when I click the button, it changes the value from 0 to 1, showing how it toggles on and off. And if I toggle back on the value of the potentiometer, you can see that it ranges from 0 here. It's jumping from 0 to 1 repeatedly because this potentiometer has a little interference, making the signal not perfectly 1. But as I turn it, you can see that the signal jumps up to the range you'd expect, right around 1023.
This is the code section for video experiment number 6 and 7. First thing that's happening here is we're making a constant variable, integer variable, that's called motor pin, and the pin that this is plugged into is number 9, as you see. Next thing that's happening is we're making a variable for the potentiometer pin, just to let the code know what pin the potentiometer is plugged into. Then we have the variables for all 6 of the LEDs in the LED array, and there are the pin numbers respectively. Here, we have a variable that measures the map of the potentiometer value to the PWM range, which I'll get into later. Next, we have another variable. This time it's for what pin the button is plugged into. Here we have a Boolean variable, which just sets the variable of lights to false. The lights variable is what is used to toggle on and off the lights in the code. In our void setup, we just have something to start the serial monitor up at the top here. And then we have setting the motor pin to an output and setting the button to an input, which uses this lights variable eventually. In our void loop, this is just what repeats the code and just repeats it, I guess, yeah. And first thing we're doing in the loop is we're creating a variable called button state, which just means digital read what variable button is doing. So digital read pin 11, which is what the button plugs into. We next have a variable called pot value, which is similar to button state. It's just analog read variable pot, and variable pot is just pin 1, so analog read pin 1. Here is where that PWM variable comes in. PWM value, it's declared up here. PWM value equals the map of the pot value to the range of PWM. That's what this 0 to 225 means. It's the range of PWM. The PWM can simulate analog value. That's why there's analog write instead of digital right here, because we're analog writing variable motor pin the value of PWM. So it can make the speed slower, high, or in the middle somewhere, depending on the value of the potentiometer. This is how you can get that big variation in speed, like any speed you want between the high and low. Next, we have some stuff for serial monitor, just for sight purposes. It just prints the word lights and then prints the value of lights, like if the button is high or low. Remember, I talked about that variable up here. And then same thing for this. It prints pot value and then prints what the value is. So it just says pot value and then number to make it more easy to see. Here's what controls the lights. The first thing that's here is if the button state equals low, if the variable that tracks the button says that the button is low, change lights to not lights, meaning change lights equals false to lights equals true. And then add a delay so it can't actually trigger again and go back to false. This allows all of the code from here down to work because it all has something that requires lights to be true. And then this if not light section here with all the LEDs low means that if it's false, have every LED off because we toggle the button off. But like I said, this code here is just turn on this first LED if the lights is true, if this was triggered, and if pot values between these two values. And then every single other one of these sections just gets one more light. So this one has 2, this one has 3 lights on, this one has 4 lights on, this one has 5, and then this one has all of them on. And every single one just increases the pot value they're on So when you turn the dial up more, the speed goes up and more lights go on if you toggle them on. And that's just what the void loop does. It just repeatedly runs checks to see if anything's changed, and if nothing's changed, it'll just keep it how it is. That's the code section.